Good morning, students. Today we will discuss center pressure of a compound body. Compound body means a body which consists of two or more plane areas. So, to find the center pressure of such body, let us take P1, P2, P3 up to Pn. These are the resultant thrusts on the n plane surfaces, and the depth of their center of pressure below the free surface is x1, x2, x3 up to xn. Then the center of pressure of the combined area, that is given by x bar, is equal to P1 into x1 plus P2 into x2 plus so on up to Pn into xn upon P1 plus P2 plus P3 and so on up to Pn. So to find the center pressure of compound body, we will use this formula. So in this formula, we are required the thrusts on all the parts of the body and the depth of their center pressures below the free surfaces. And in the next formula, we are having center of pressure of a particular part of a body. If we are having a body, for example, you are having this body ADE, and this is its particular part, we are to find the center pressure of this part. To find the center pressure of this part of this body, you will have to find the thrust on this whole body, then the thrust on this part, and the depth of center pressure of the total area, as well as the depth of center pressure of this area. Then the formula here becomes P into x bar minus P1 into x1 upon P minus P1. Here P is the thrust on the whole body, and P1 is a thrust on the part of the area which is cut off from this plane area, means this area, and x bar, that is the depth of center pressure of total area, and x1 is the depth of center pressure of area cut off, means this area. So we'll use this formula to find the center of pressure of a particular part of a body. Now, our first problem is prove that depth of center of pressure of a trapezium with side A in the free surface and parallel side B at a depth h below the free surface is given by h by 2 into a plus 3b upon a plus 2b. So here we are having a trapezium A, B, C, D. AB and DC, these are the parallel sides. The length of side AB is A, length of side DC, that is B. We are to find the depth of center of pressure of this trapezium. Now, let us divide this trapezium into two triangles by joining the point B to D. So, this trapezium is regarded as a compound body consisting of two triangles. One of the triangle is triangle ABD and second triangle is the triangle BDC. So, to use the formula which we discussed, we will have to find the thrusts on these two triangles as well as the depth of their center pressures below the free surface. So, let us find them one by one. First of all, let us find the depth of center of pressure of triangle ABD. In the first exercise, we already discussed when a triangle is having one side in the free surface and the vertex downward. In that case, the depth of its center of pressure is given by h by 2, where h is the height of that triangle. And if a triangle is having the vertex in the free surface and base horizontal, in that case its depth of center pressure lies at 3 by 4 of the total height of the triangle. So you will have to keep in mind the center of pressures of all the standard areas like triangle, rectangle, circle, etc. So here, by using those formulas, depth of center of pressure of this triangle, that is h by 2, and the depth of center of pressure of triangle BDC, that is 3 upon 4 h. Now, let us find the thrust on these two triangles. So firstly, thrust on triangle ABD. This is, we have denoted by P1, and it is given by pressure at the center of gravity into the area of the triangle. Now pressure at center of gravity is given by rho into G into the depth of these three vertices from the free surface. Depth of point A from the free surface is 0. Depth of B from the free surface is 0. Depth of D from the free surface is h. So the height here is obtained by the arithmetic mean of perpendicular distances of the three vertices from the free surface. That will be h by 3 here. This is the pressure at center of gravity. Into area of triangle, this is half into base into height. Base of the triangle is AB, which is length A, and the height of the triangle is h. So we have obtained P1, which is rho G A h square upon 6. Now we find the thrust on the triangle DBC by the same formula. This thrust we have denoted by P2. So this is given by pressure at the center of gravity into area of triangle DBC. Now density we have taken as rho into G into the depth of the vertices of this triangle. The depth of vertex B is 0. Depth of vertex D below the free surface is h. Depth of C below the free surface is also h. So arithmetic mean of the three depths will be 0 plus h by 3, 2h by 3, into the area of triangle DBC, which is half into base into height. Base of the triangle BDC is DC, having the length B, and height is h. So we have obtained the values of all the four terms, x1, x2, p1, p2. Now we can use the formula to find the center of pressure of compound body, which is given by x bar is equal to p1 into x1 plus p2 into x2 upon p1 plus p2. Now because we have obtained all the four values, we can put those values here and simplify to get the value of x bar, which gives us the depth of center of pressure of the trapezium, and which is given by half of a plus 3b upon a plus 2b into h. Now our next problem is, if P is center of pressure of a rectangle ABCD, the side AB being in the free surface, we are to prove that the line through A and P divides the area into two portions, the thrusts on which are equal. So let us take a rectangle ABCD. The side AB is in the free surface. Let us take x bar is the depth of center of pressure of this rectangle. Now, as we discussed earlier, the depth of center of pressure from the free surface of the rectangle lies at 2/3 of this length. The length AD is B here. So the value of x bar will be 2/3 of B. Thus, the center pressure of rectangle ABCD is at the depth 2/3 of B. Now, let us find the thrust on this whole rectangle ABCD by the formula. This is given by pressure at the center of gravity into area of this rectangle. Now pressure at center of gravity is given by rho into G into, here the depth of vertices is 0, its depth from the free surface is 0, its depth from the free surface is B, its depth from the free surface is B. So this will become 0 plus 0 plus B plus P divided by 4. That will be B by 2. And area of the rectangle is length into breadth. So that will be AB. So we have obtained the thrust on the rectangle ABCD, which is given by rho into G into AB square by 2. Now, because we are given that the line through A and P, there is a line which is passing through A and P, which divides this rectangle into two areas. We have to prove that the thrust on this triangular area and this area ABCQ, that is same. Now let us find the thrust on triangle area ADQ. Again by the formula, this is given by pressure at center of gravity into area of triangle. Pressure at center of gravity, that is given by rho into G into height is given by 0 plus B divided by 3. Area of this triangle is half into base into height. Height of the triangle ADQ, that is B, base is DQ. So we have substituted the value. Now what is DQ? In this triangle you can see DQ is DN plus NQ. So we can put the value of DQ as DN plus NQ. Now what is DN? Because N is the midpoint of DC. So DN will be half of DC. This whole length is A. So DN will be A by 2. Now it remains to find NQ. Now because the triangles, triangle AMP and triangle NPQ, these are similar triangles. And if the triangles are similar, the ratio of their corresponding sides are same. So the ratio of the side NQ with the side AM, that will be is equal to the height PN upon the height PM. So we can put the values to get the value of NQ, which is A upon 4. Putting the value here, we have obtained the thrust on the triangular area ADQ. Now we are to find the thrust on the quadrilateral area AQCB. Now because we have obtained the thrust on this whole rectangular area and the thrust on this triangular area also, so if we subtract them, we will get the thrust on this part. So the thrust on the quadrilateral area AQCB, that is given by subtracting the thrust on the rectangular area and the thrust on the triangular area ADQ. So putting the values, we have obtained this thrust as 1 by 4 rho G AB square, which we can see that is same as the thrust on the triangular area ADQ. So this proves that the thrust on the two portions are same. Now there is one more problem to see. A quadrilateral lamina ABCD has the side CD in the free surface and the sides AD and BC are vertical, having the lengths A and B respectively. And we are to find the depth of center of pressure, and to prove that it is half of the expression A raised to the power 4 minus B raised to the power 4 upon A cube minus B cube. So let us take this quadrilateral area ABCD having the sides AD and BC vertical. This length is A, length BC is B, side CD in the free surface. To find its depth of center of pressure, we are to find the thrusts on some standard figures. So let us extend the line AB till the point E, so that the line DC is extended up to E. So we get a triangular area ADE. To find the depth of central pressure of this area, we require thrust on this whole body, thrust on this body, and depth of central pressure of this triangle as well as the whole triangle. So let us find these four terms one by one. So first of all, we find the thrust on the whole body, means triangle ADE. So by the formula, this is pressure at center of gravity into area of the triangle. Pressure at center of gravity is given by rho into G into depth of center of gravity is given by 0 plus A by 3. Area of this triangle, this is right angle triangle, so area will be half into base into height. So we get the thrust on this whole body, which is given by 1 by 6 into rho into G into A square into the length ED. Now let us find the depth of center pressure of this triangular area ADE. Because here the side is in the free surface and vertex is downward, so the depth of center pressure, that is given by height of the triangle by 2. So that will be A by 2. Now it remains to find the depth of center pressure and thrust on this triangular area. So the thrust on the triangular area EBC, that is given by rho into G into depth of its center of gravity is 0 plus B by 3. Area of triangle is half into base into height. Because the triangle is right angled, its base is CE and the height is B. So putting the values, we get the value of thrust on this triangle EBC. This thrust is given by 1 by 6 into rho into G into B square into EC. Now here again, because this triangular area is having the base horizontal and is in the free surface, vertex downward, so the depth of center of pressure of this triangular area, that will be its height upon 2. So that will be B by 2. So we have obtained all the four values. Now we can substitute these values in the formula to get the depth of center of pressure of quadrilateral lamina, which is given by P into x bar minus P1 into x1 upon P minus P1. Putting all the four values P, P1, x1, x bar, and taking ED common from numerator as well as denominator. So inside we are left with A cube minus B cube into EC upon ED, and in the denominator we have 2ED into A square minus B square into EC upon ED. Now ED is cancelled with ED and we are to find the values of EC upon ED to put here. Now to find their values, we can use the similarity of the triangles. Now the triangle BCE and the triangle AED, these two triangles are similar triangles. So the ratio of their corresponding sides will be same. If we take the side EC of this triangle, then EC upon ED is equal to the side BC upon AD. So we have obtained the value of the ratio EC upon ED is equal to BC upon AD. And substituting the value of BC and AD is the length A, BC is the length B. So we have obtained the ratio EC upon ED. Now we can put these values in the formula which we applied the depth of center pressure of quadrilateral area. After substituting the value and simplifying this expression, we get the depth of center of pressure of the quadrilateral lamina, which is given by half of A raised to the power 4 minus B raised to the power 4 upon A cube minus B cube. So these were some of the examples how to find the center pressure of compound body. There are two more examples based on this. and you will try these two examples yourselves. And if you have any problem in these two examples, we will discuss it in our doubt class.